fiber, structural in a broader way. So matrix, it is PMC, what I can say, polymer, metal matrix, and ceramic matrix. Like, and coming to the rule of mixtures. So of course, everything you have to evaluate. The engineers, okay, engineering is derived from the word ingenuity, in the sense application of mind. What experiment and evaluate, no doubt about it. But always validation is required very much. Validation in the sense how we can estimate the predicted strength of the composite that is formed. For that, we have a rule called as the rule of mixture. It is quite interesting. So you can validate. So maybe density or strength or something like that, that you can predict based on the materials that you are combining to form the composite. Theoretically, you can evaluate. So if you are going to get the desired strength, then you can go for fabrication or vice versa. I mean, validation also is required. Validation in the sense whether you are attaining as per your theoretical, because in the experimental stage, there may be some limitations to form the material and all. And of course, you may not get 100% validation. You should be very closer to 90-95%. So what is this rule of mixtures like? So as I told, okay, you are going to combine in the form of volume fraction or mass fraction or something like that. So according to the rule of mixtures, theoretical properties, I mean, like analysis will do by using the software tools, ANSYS and all, like structural analysis, like that. So using some equations or so using some rule, you can obtain or you can evaluate the properties. Like according to the rule of mixtures, theoretical properties of the composites can be estimated as discussed below. For example, if it is density, so DC, let us say density of the composite. D stands for density, C stands for composite. So you have used two different materials, you have formed composite like. Then what will be the density? Of course, density. So after formation of the composite, you can weigh and you can check it. That becomes experimental evaluation. But this is the theoretical evaluation. dm multiplied by, please note that it is multiplication symbol, Vm. So what is this Vm, dm and all will see, plus df into Vf like. So it's a simple like simple mathematics or simple arithmetic, what I can say, where dc, dm, df are the densities of the composite respectively, of course, matrix and dispersed space, and Vm, Vf are the volume fractions, how much volume, for example, 5%, 10%, like that, okay, you'll add. And you'll be knowing the properties. Before combining, you'll be knowing the properties. So what is the volume you will decide. Density, it is predetermined. I mean, it will be available in the data, like what is the density of, for example, fly ash? What is the density of mica? So like that. So what is the density of aluminum 7075 material? Okay, I mean, matrix material. So like that, you will be knowing the properties of the individual materials that you are going to combine. Volume fraction you are going to decide. I mean, you are going to add accordingly or according to requirement. So then, so using this formula, so centimeter and cubic mm or whatever it is, so you can evaluate and you can validate or compare like. And similarly, the modulus of elasticity, so you can calculate using this, like using this equation on the same grounds, what I can say. Only thing is, okay, in place of D, ES come into the picture, like what. So these are the modulus of elasticity of the individual metals that we are going to combine, and these are the volume fractions of the respective materials. So coming to the tensile strength, same in the same way, tensile strength of a long fiber reinforced composite. So in a longitudinal direction or in general, so you can obtain like this. So again, what means sigma C stands for, so composite tensile strength, and this is the matrix tensile strength. This is the F stands for reinforcement or something like that. So I mean, sigma stands for tensile strength of matrix. This is of reinforcement and respect to volume fractions, like. So this is about rule of mixtures, like. Now coming to the new advancements. So as I told, materials are classified as metals and alloys, or metals and non-metals basically. So of course, metals are classified again as ferrous, non-ferrous. Okay, all these things, okay, you have seen, and you are well versed, it seems. Okay, so and coming to the present era or present research that is going on, even composites with a single fiber or single reinforcement is outdated, I can say, like. I mean, so we are not in a position to get the desired properties with one or single reinforcement. So in that, it is not hybrid and hybrid composites, sorry, it is advanced or hybrid composites, I can say. Advanced or hybrid composites. Hybrid composites are relatively new and obtained by using two or more different, it not be two. The rule of mixtures, of course, you can use even if you have more than 2 also. Or even you can computerize it. You can write a program for it to evaluate. No need to calculate everything manually. If you feed the data or properties, so instantly it will give the theoretical results, even if you have more reinforcements also, because the equation becomes lengthy, no? So in that sense, I'm telling. So more different kinds of fibers in a single matrix. Hybrid composites have a better all-round combination of properties than the composites containing only a single fiber or single reinforcement, as I told. And this is one sample of this one, ingots of aluminum 7075. This is an alloy. So basically, it was in use for the aircraft, this one 7075. And the limitation of this is, again, no doubt, is a good material having high strength and all, but density relatively more, but less than compared to structural steel or mild steel and all. Alloy it became now intermediate metal alloy. So this is the E-glass short fibers. So I have worked on this for my PhD from Jain to Hyderabad. So fly ash particulates. So this is the fly ash particulates. Okay, like what I can say, throwaway price will get the fly ash, or sometimes they'll give it free of cost also, because they'll dump in the power plants in a very this one, I mean, huge way. So even they want to transport it, so they'll give or they'll provide it free of cost. This you can use as an engineering material that you can prove. Again, fly ash. So there are different types of this one, chinosphere, grain size or something like it depends. E-glass again, short fibers. This is an illustration. So where more than one reinforcement is used, hence it is a hybrid composite. I mean, if you combine by a suitable fabrication technique or formation technique, this ingots of aluminum 7075 with these two, it will become hybrid composite. So our advanced composite, we can say. Now coming to the limitations, of course, we do have some limitations or challenges of the composites. Of course, there will be scope for future work, I'll be telling, like that. So high cost of raw materials, cost, so sometimes we need not see about the cost or something like, so requirement is very important. High cost of raw materials and formation. Composites are more brittle than rock materials, I mean, the regular or conventional materials, and hence they may be damaged sometimes, in not all cases. So these are few limitations, what I can say. Reuse and disposal in some cases may be difficult. Analysis of the properties is relatively difficult. Of course, now, because we're in the era of computation or information technology, this will become easy. As I told, you can feed and you can evaluate the properties very easily. You can write a program and you can evaluate. And still we are facing in some cases the analysis of the properties as a little bit difficult. Coming to the areas of application, of course, anywhere to everywhere composites are there. So you mentioned automobile, marine, or even space vehicle, all these things. So aircraft, missile, space sector, marine automobile applications, recreational, I mean sports, and all these things, sports goods, in electrical and electronics. All these are the broader areas of application. So just you can see a few snaps or a few pictures. So where the composites are involved, or the applications of the composites, right? So composites in action, same thing continues. Okay, like maybe sports vehicles or automobiles. So are for recreation, all these things. And apart from this, just I wanted to give some gist of information about role of manufacturing, because once if you understand about the material, little bit knowledge of manufacturing is also required. That too have taken as continuous of this, the role of green manufacturing. So this is very new topic, what I can say. The concept of green for the future or for growth or something like, green manufacturing is gaining much attention or much focus, my dear friends. Green in the sense generally, it's not production of green product or coloring the product as green or something like. So it is again related to the materials concept only. I mean, if you use the materials which are not harmful to the nature, so that itself is a green concept or green manufacturing. What it is, there is a close relation between these two. Sustainability in manufacturing is a competitive need of the hour. With increasing global warming, industrial waste, so that's what as I was telling, fly ash and all is industrial waste. So that disposal of fly ash is a big problem, and it's creating new problems to the nearby people who are living. Non-biodegradable production. Green is becoming an important strategy in the manufacturing sector. Then what is this green manufacturing or green products, green materials, all these things? Green manufacturing is a method of manufacturing which minimizes the waste and pollution through an effective product and process design. Like, I mean, so you might have heard about JIT, Japanese technology, just in time, all these things like. So long back, okay, they implemented, but I'm not linking JIT to manufacturing, this green manufacturing. Just an example I'm giving. So green manufacturing is a method of manufacturing that minimizes the inventory or minimizes the waste and pollution through an effective product and process design. It is an economized manufacturing process that tends to exploit all the available resources, reusable wastes, and thus relieving the concept of environmental sustainability. So this is very, very important. Simply if you develop the materials, so of course, disposal, the environmental sustainability, that also matters. Like, so that is the reason why I have taken this in addition to that. So it encompasses, in other words, it emphasizes, it focuses ease and reducing parts of structure, parts of emission, or so. So rationalizing the materials. So all the resources we should use like a ration. So it is like a property of the nation, what I can say, we should use like a ration, what I mean. So, and reuse in the components. All this, put together is termed as green concept or green manufacturing. And coming to this, one more, this one just a continuation of this. Manufacturing of green products, that means producing those products which uses less natural resources and can be reusable and recyclable. So again, this is linked to material. While developing the materials, we should think of this also, whether they are recyclable or reusable, all these things. So not only formation of new composites or new materials, so the challenge is about their disposal, about their reuse also matter. Reuse, reduce, recycle. In a nutshell, this is the concept of green product or green manufacturing. So which is made up of some materials, of course. Reuse, the material should be so in a position to reuse, and reduce the number of parts, or reduce the size, reduce the weight, maybe anything to everything like that. Recycle like. So after some utilization or something like, we should be in a position to utilize 3 R's, R. So reuse, reduce, and recycle. Coming to the outline of this green manufacturing, implementing any kind of substitution in the manufacturing process. Already there is manufacturing, no doubt. So what is this? Implementing any kind of substitution in the manufacturing process which leads to the reduction in energy consumption. This is very, very important. So reduction in the energy consumption during the formation, like resource consumption, energy consumption, waste by products and waste byproducts. So many byproducts will use in the formation of a raw material, or in the formation of a new product. Like any product, it should have good aesthetics, no doubt, ergonomics, that is comfort to use, and function. AEF will call in product design, aesthetics, ergonomics, and function. So in attaining these three, so many byproducts will be used, but we have to minimize those byproducts in attaining the attributes of a successful product. So, and waste uses. Green manufacturing is the renewal of production processes and the establishment of environmentally friendly operations with the manufacturing field. Of course, greening of manufacturing. So, I mean, all this put together is called greening of manufacturing. No doubt to have the manufacturing. So just to make it green, like natural resources, lowering the natural resources, pollution and waste, and maybe the weight. So all these things like, so harmful emissions, all these things, if you minimize, that will become green manufacturing, green product, or green material or something like that. Now, what the green means, green stands for ecological sustainability and encompasses many different concepts, including maybe air, water, all this is natural resources, land pollution, energy usage, efficiency, waste generation, and recycling. Green initiatives aim to minimize the impact of human activities on the environment. No doubt, we need the product, we need the structures, we need to upgrade our infrastructure, we need to build automobiles. So that is a continuous process. So no doubt, they'll decrease. They'll keep on increasing. But at the same time, so some initiatives, green initiatives, so they aim to minimize the impact of human activities on the environment. In such a way, you have to think about the future energy sources or future materials or generations. So we should leave some resources and other things for the future generations also. That is like our concern. It should be our concern and top priority. It's like that. So green manufacturing is a philosophy. So rather than calling it as a technical concept or process, it is a philosophy. Self-discipline, or everybody should imbibe this kind of concepts. Like it's a philosophy rather than an adopted process. It is a holistic endeavor intended to, of course, the object is what I can say: minimize the waste, produce cleaner products and processes, of course, a better and safer working environment, and build the relationship between companies and the local communities. There will be clash always. So when there is a dump of some unwanted material, something like that. So again, it is leading to some problems, societal problems. So there should be harmonial relation or cordial relationship between the companies as well as the local communities also. That is the objective. So enhancement of the profitability and competitiveness again. So this is also one of the objective. Then how we can transform green manufacturing, transformation to green manufacturing. So green energy, green processes, green products finally. So the next one, okay, it is the green manufacturing. Green initiatives in the power sector, how the maximum impact on reducing CO2 emissions. So this is again a big threat to the environment. So part of the civil engineering, like, so again, it leads to many problems if there is much emission of CO2, like followed by transportation and then the industrial sector. So there will be maximum release of carbon dioxide, sorry. So in the transportation and the industrial sector, like. So whereas if you adopt the green philosophy, so it may reduce to the maximum extent, to possible extent. So any product, to be successful, of course, no doubt you need the good material. So without that, no product exists, as respected principles has pointed out. Without material, you cannot imagine any product. Only services, okay. So even to give the service, you need some material. So to work on the computer, of course, computer may be a device which computes, but basically it is made of some material. So that is giving service, but the basic thing is the material. So life cycle approaches of product design. So always, okay, you have to think of the three things, what I can say: design for reuse, design for disassembly. So it should not be very complex, okay, if you want to dismantle or disassemble. Design for remanufacture, like in such a way. So you have to think of the materials also, selection of the materials as the concept of green manufacturing and green philosophy. Design for remanufacture, like. So coming to the goal of green manufacturing in one line, the purpose is to support future generations, as I pointed it out sometime, by attaining the sustainability by means of preserving the existing natural resources. So this is the holistic approach or single point agenda, what I can say about the green manufacturing. So coming to the benefits of the green manufacturing, it creates a great reputation to the public. The reputation of a company to the public is always an important thing, because it can float or sink a company. So unless, okay, they maintain the cordial or good relationship with the local hood or local people, sometimes it may be very difficult to run the company or to operate the company. So it creates indirectly, it creates a great reputation or good relation with the public. If a company pollutes its neighborhoods, people would begin to move away, creating a lack of employees. This is also a problem. Nobody may like to stay over there or something like that. So saves useless cost, like. So value addition, what I can say. So even if you decrease the cost indirectly, profit is increased, what we will say in economics. Eliminating waste is also like increasing the profit to an organization or to the end user, like. So eliminating waste saves money, because companies would not have to figure out what to do with parts in the end when it could be recycled, like. So that is also very important. Promotes research, like. So as I told, there is much research scope. Firms that are using green manufacturing create 2 times the products due to its research and development. Productivity also may enhance. So of course, there are some challenges in the implementation of the GM, that is green manufacturing. Biodegradable, non-toxic and recyclable materials should be used for this. Product must be designed for disassembly, as I told, and remanufacturing and reuse. Move from the traditional to the new technology. Only change is constant. To adapt to the change or to cope up with the change as change is permanent or constant, and move from the traditional to the new technologies, what upgrade. Process optimization to minimize the losses and wastes in energy and materials throughout the production process, like, and improve the end of life management of the products by that is refurbishment and reusing. Like, there are some industries, I've seen many, I've visited also, refurbishing industries, like, so same conditions, okay, they'll assure, and same product which was almost was about to become scrap, no, they'll refurbish and they'll give it to the customer. So again, so that is nothing but improve the end of life. So it is not this one end of life, it will restart, in other words, so by refurbishing and reusing it. So of course few challenges are there in implementation of this one. Businesses have a responsibility of influence. Prices of raw material and subsidized energy are essential. So still, okay, it is not having much publicity, or so I can say. Lack of availability and information. High profile leadership is required. We should think in a broader sense, bigger way, broader perspective, what I can say. Training programs need more support. So accessibility to loans from the government. So national cleaner production centers need to be established. Separate wings are required to promote this, what I can say. So of course there are a few challenges, as I told, but to overcome all those challenges we can. So these are few green products that are in use, what I can say. Doormat. So maybe this rainwater saver, what I can say. The chair, which is made up of some recyclable plastic. This is made up of recycled rubber material. Okay, we're using again as fresh material in the form of a new product, like, so recycled plastic again. So then this one cassette tape, okay, your necktie or something like. So these are few products, green products, what I can say. In continuation to that, so this is a circuit board, the laptop sleeve, so recycled box. Even this e-commerce companies like maybe Flipkart or Amazon, so they are using all this. So the recycled materials, recycled tennis ball. So this is a fluorescent, this one, like, and these are all the materials which are the examples for materials or products for green manufacturing, based on the green products or green manufacturing. So this is quite interesting. 8 recycled plastic bottles will make you one football shirt, like. So you can think of it like 8 recycled plastic bottles, water bottles or so. So we can make one football shirt. So e-ticket. So now, of course, already it is in the implementation now, paperless job. So an appeal to passengers, something they have given. Save paper, we can save almost 3 lakh A4 site every day. So if you avoid the printing wherever it is not required. If it is required, okay, if it is necessary, okay, there is no other go. So to go for it. But wherever it is not required, so no question of going for conventional printing. So few companies using the green manufacturing. So already very, I mean, a good number of companies, what I can say. So I've implemented Nike, that T-shirt and all I was telling, no. So like that Toyota, so Coca-Cola, Dell, all this HP, Tesla, Honda, all these things. I mean, all these notable companies are using the green practice. They are in practice of the green manufacturing and usage of the green products, like. So keep this planet clean is the motto of all these things. Maybe development of new materials and all these things. So this pictures of these slides will show few more products. Use biodegradable cleaners. So that's what, as I told. Print on eco-friendly paper. Use compact fluorescent or LED lights to the possible extent. Encourage a green commute. Alternate energy sources. It is also like great service to the society, using of alternate energy sources, maybe solar energy, wind energy, all these things, like. So that is also part of green energy, promoting the green energy. So energy conservation, because 1 unit of saving is equal to 2 units of production. 1 rupee saving is equal to 2 rupees earning, will be thinking, like that. So energy conservation. So shut down machines not in use, or the lights or anything which is not in use or something like. They're also part of it. Replace the old appliances. Sometimes the maintenance cost will dramatically increase if you're using the old appliances. So somewhere, okay, you have to replace. There is a concept called as replacement analysis itself for that. So where, okay, break even you cross, I mean, maintenance becomes more than the cost of new product or something like, then okay, you have to be being engineers. So you have to be very wise to replace the old appliances wherever is required. Reduce the waste, of course, this is covered. Reuse of the material. So efficient fuels, use cleaner fuels, cleaner and efficient, what I can say, for generating power, biomass, the hydropower, all these things. Green transportation, electric vehicles, fuel cells, and biodiesel are some of the examples of this category. Biodiesel, okay, is gaining focus. So there's also reduces the emission of CO2 and which will minimize the impact and the burden in the environment or nature. And ultimately the recycle. So to keep using to the possible extent the materials. And that's what I wanted to convey in the given or allotted time slot, my dear friends. I take this opportunity to thank you one and all for your kind attention throughout my presentation. Kindly pardon me if I was hurry or fast, because optimization, I believe always, optimization means giving more in the less time. My specialization also partly optimization, subject to the constraints, of course, but to maximize the learning part also, I believe. So that I have tried my best, I hope. Is it audible, madam? Is it okay? Clear everything? Sir, professors? Hello? Hello?
Professor.
Professor, is it audible, sir? Is there any technical issue? No, nothing. Hello, sir, madam.
Hello. Hello.
Hello, sir.
You can talk like that only, sir.
We'll first open the question and answer session.
Sir?
Professor, we'll go for question and answer session.
Yeah, please, sir, please. I hope my presentation was useful, sir, professor. Any other participants, please let me know. Okay, I value your feedback and I'll always value your views. Let us work towards the excellence.
Sir, please, can I?
Yeah, please, sir.
Sir, it's a great honor to listen this class, sir, first. And I have one doubt for me, sir.
Yeah, please, sir, please proceed.
How the research strands are going on to do for, I'm a PhD scholar, sir.
Okay.
So how it will help to me to define a new object for any type of PhD thesis?
Okay. Objectives means, sir, based on the end use. For example, what may be the end use of that? Based on that, so you have to define the objectives. Like, are you in which stage, sir? May I know? Like in the initial stage or?
I'm an initial stage, sir.
Okay, fine. Objectives in the sense, you have to find the research gap first. So what is done in that area, and you have to go through the various published papers. What is there? What is the scope for your work? Continue somebody's work also. See, research may not be every time completely new. It may be the continuation of somebody's work with, of course,
yes,
So you have to find the research gap, in other words, my dear sir.
Sure.
Then, okay, based on the end use, you have to keep something in the, for example, if you are developing a material, what is the use of that material? Whether you are going to use in the marine or aircraft or some other purpose or something like structural purpose. Based on that, you have to carry out the tests to the possible extent. So there is no point of conducting several tests. For example, if it is used in the corrosion environment or high temperature environment, then you have to go for creep or corrosion. So like that, you try to define the objectives in the beginning. That's one thing.
Okay.
And okay, I have given my contact details also. Please, feel free to be in touch, for any this one also. Take a note of my mail or number also.
Sure, sir. Sure.
Please, I wish you all the best, sir. Okay, that's what two things. Research gap you find, what is done, what is to be done, what is the scope for you to carry out or to take up that work, and what is the end use of that work, societal use or maybe industrial use. So
Sure.
these two you have to keep in mind, sir, mainly.
Sure, sir. Sure, sure. I will contact you, sir, personally after this.
Sure, sure. By all means, by all means. My pleasure, sir. It's my pleasure always.
Thank you. Thank you very much.
Thank you, thank you, thank you. I appreciate your concern and listeners' interest.
Any more questions from the participants in? Sir, one question.
Yes, sir. Please, sir. Please, sir. Yes, sir.
Chat box lo ఒక క్వశ్చన్ వచ్చింది.
చెప్పండి సార్, ప్లీజ్ సార్. నేను చూడలేదు, చాట్ బాక్స్ చూడలేదు, చెప్పండి సార్.
Getting the chat box.
Sir, they are asking, sir, what are current materials in metal matrix composites?
Okay, madam.
What are current materials in metal matrix composites?
Yeah. Okay, madam. We'll discuss, madam. So, metal matrix composites, MMCs. Of course, the series of alloys, madam, basically in the matrix, right from 2002, this one, 2000, 3000 series, like that. So, 7075, I've given an example. So, like that, there's a metal, alloy-based, aluminum alloy-based matrices are going on, madam, mainly. Because aluminum is having much, having very good properties in all aspects, except the strength. It is having ductility, good ductility, formability, then even what I can say, conductivity, in terms of conductivity also. That's why you can say that MMCs, mainly though you have many metals, aluminum-based metal matrix are having much scope or significance. Any series, let it be 2000 series, 6000 series, marine applications, 7000 series, structural applications, and of course reinforcement you can vary, but especially aluminum-based metal matrix composites are having much focus, madam.
Morning, myself, Dr. Ashish Urade from Nagpur. Am I audible?
Yeah, please, sir. Please, audible, sir.
Sir, I have asked that question, so you answered nicely.
Oh, thank you, sir. Very nice of you, sir.
There are
And of course, there are many other metals
yes.
also, sir. But much work is going on based on the points that are made.
Yes, because what I see, there are two trends, sir, for metal matrix composites.
Yes, sir.
The first trend is in terms of, we can say, research aspects, like in aerospace and other high-grade institutes. And second is in terms of industry orientation,
Yes,
commercial
sir.
aspects. So my question is in that regard, that whether the two trends are differing from each other from the research point to the commercial aspect
Very
point in the
good thought,
industry.
sir. Appreciate your excellent thought-provoking question. Really, is a great question. Normally, okay, we'll think from research point of view. Research point of view in the sense to enhance the engineering properties.
Yes.
So engineering properties means having a high strength, low density, like that. So more or less, okay, aluminum based metal matrix, no, sir. Okay, cost wise also they are effective when compared to other matrix materials. So commercial also they are viable. What I opine, sir. Commercially as well as for the research point of also. So they are suitable, like blend. In the sense, both the things are like two faces of the coin, as you told. Research is also important. At the same time, cost is also, or commercial aspects also important. And of course, there are a few more materials that are coming, sir. They are replacing the aluminum alloys. Also heard, but still okay. So yet to wait, sir. As of now, that is this one, sir. Bottom line.
Okay, sir.
It's a very good question, sir. Okay, so much insight how in the question. Sincere appreciation, sir.
Yes.
Yeah, one of our young friend was asking about this one, sir. Objectives. I think you can take these points also. Your valuable input you can take.
Yes,
commercial
yes, yes.
aspect as well as research. What are the objectives that I have to define like that? One of predecessor was asking. I mean,
Yes,
participant previous question. So certainly it will be a great input or suggestion to him. We can we can take the commercial aspects as well as research aspects. Based
Always,
on that, you can set the
always
objective.
for this, better to go to the industries and find out the new aspects.
Yes, yes. We are academicians normally will not think much about commercials.
Yes.
Even then, being an engineer, we should think of that, sir.
Yes, yes. Okay, sir. It's over from my end.
Thank you.
Thank you.
Sir, here one person asked one question.
Yes, madam. Please, madam.
Shall we use any new composite material for high temperature application? And what is the research scope for this composite material for weldability point of view?
Okay. Please pardon me, madam. You repeat high temperature.
High temperature application.
Yes,
And
madam.
what is the research scope for this composite material for weldability
Yeah.
point of view?
Okay, madam. Good question again. One more good question.
Okay.
And sometimes the materials may have to be used in the elevated temperatures. For example, aircraft material or space material and all that will not be used at room temperature. So room temperature means maybe 40 degree, 50 degree or something. Recently, maybe 1 year back, I think. So when I visited IASC, which is very closer by to our institution, so a lot of work is going on in that, sir or madam. I mean, they've created a closed chamber for that, and they are experimenting, and they are not given the details about that much about that. But separate experimental setup they have made in IASC to test the materials at high temperatures. Because elevated temperatures in the sense, okay, maybe in terms of 100 degrees, hundreds of degrees like. So even the weldability also is an issue. So when they are supposed to be used at higher temperatures, by default they should be weldable. So in some separate chamber they have created. Even we tried to one of my research scholar, but they have not permitted us to this one know much details. But some research is going on. But it's a lot of investment is required to equip ourselves. So why? Because that separate chamber, separate equipment, cost, in terms of cost, it may be more, but it is going on. That much I can say, madam, at this point. It is there, scope is there for that also. So it's a really great. Yes, madam, please, madam, please.
Participants have any queries, you can ask now.
So even it is a great opportunity to update myself, to learn more from the questions. Always, okay, one should think like that. So it is also an opportunity to exchange your views. So need not be the doubt or something like, it's like discussion. So it may clarify the doubt of others also. It may be helpful for others also, sure. Directly or indirectly.
Yeah, sure, sir.
It is towards the excellence, madam, in a single word. So we're not testing anybody's knowledge or so. It is an exchange for excellence, our views.
Yeah, sir. Sir, thank you for your influential message, sir.
Okay, madam. Very kind of you, madam.
Sir, anybody having any doubts, you can ask now, so that we can wind up the session now. Okay.
Madam,
now the problem.
One line. I take this opportunity to express my sincere thanks to honorable management, respected principal, respected HOD, Dr. Raja Reddy sir, who has connected me basically to this session, and Professor Archana, who has introduced very nicely about me. Coincidentally, she was my PG student, PG project guide. I was, in fact, and of course, all other HODs, teaching and non-teaching staff members, and all the vibrant participants. Really, I'm grateful to you for being part of this. Really, I learned something. Always, I think, take away. Even okay, not only I might have delivered a lecture, but even I learned a few things. Always, every day is a learning day. Pachatantra says that is my opinion or my viewpoint. So once again, my sincere gratitude to all of you, those who are connected directly and indirectly. And I wish you all the best for this 1 week FDP program also. Sir, respected HOD, sir, Civil HOD and Mechanical HOD, special thanks to you, sir. Madam.
Hello.
Yes, madam. Over to you, sir. Over to you, sir.
Nothing special.
Yes, sir. Please, sir.
It's just formality sake.
Yeah. Done, sir. So I think it's 11:40. If anything is there, we'll discuss. Otherwise, okay, this one, sir.
It's over to Archana Madam for you. Vote of thanks.
Good morning, sir.
Very good morning. Good afternoon, ma. Very good afternoon. Good morning. Sorry, ma. Sorry.
It's okay. I think you remembered me, sir.
Yes, ma. Please, ma. Please.
Thanks a lot, sir, for accepting our invitation.
It's my pleasure, ma.
Okay, once again, good morning, everyone. Now we are going to wind up our session. A lovely and warm morning to our most valued and worthy guests, management, principal, faculties, and students. It's a matter of pride for me that I'm proposing a vote of thanks for this session. I, on behalf of our management, principal, and colleagues, my most sincere thanks to the speaker of the day, Dr. N. Srinivas Reddy, sir, who gave his vital time for his busy schedule to grace this FDP. I would like to thank Vijay Bhaskar Reddy, sir, for all his support and encouragement. I also thank our beloved principal for his guidance in carrying out program. I would like to please my hearty thanks to all the coordinators, HODs, and participants, because of whom we made this session possible. Once again, I would like to state that we are glad to have the speaker here over this session. We thank you, sir, for being with us. It has remained a pronounced pleasure. Have a great day ahead. Thank you, sir. Thanks a lot.
Thank you, ma'am.
everyone.
Thank you very much. Thank you.
Thank you, sir. Thank you so much.
Thank you, ma'am. Thank you, professors. Thank you all. Thank you all. It's my honor, I feel. Thank you. Very kind of you for giving me this wonderful opportunity to connect with you people. So really, it's a notable and noble occasion, we can say, as the respected HOD told, it's August gathering. Really, fine. Thank you.
Okay, sir. Thank you.
Okay, professors. Thank you all. Thank you all. Have a nice time ahead, sir. Okay, madams.
Thank you, sir. Thank you so much.